Agunusha Korja is Mishapola Kunigon. Hello and welcome to the third day of IST-Africa 2022. Today we're focused around core technologies, including next generation technology. We're starting with content technologies, which is obviously extremely important in an African context. And we have a number of presentations from Tanzania, from Kenya, from South Africa, and from Ghana. So we're starting with Alex, who's going to discuss perceptual impacts of wireless network impairments on video streaming QoE using a Taguchi approach.
Good day, everyone. My name is Alex Mongi. I'm a lecturer at the Department of Electronics and Telecommunications Engineering of the University of Dodoma, and I'm here to share with you my research paper titled Perceptual Impact of Wireless Network Impairment on Video Streaming Quality of Experience using Taguchi Approach. And this is my presentation overview. And I'm going to talk about 7 points in this presentation. We understand that video streaming is an internet-based technology to play video files, and it do so by doing packet-by-packet playing video files on smart devices like computer and mobile phones, etc. And unlike the traditional video technology, this video streaming type of playing video files depends on internet technology. Statistics shows that globally video streaming has increased due to an increase of smartphones. There are about 6.3 billion smart devices and 300 million mobile personal computers and tablets. This is according to Ericsson report of 2020. This stimulates a wide range of innovations in video and internet applications. And also the report by Cisco predicts that by 2026, the mobile network traffic will be accounted by video streaming applications to about 77%. This is a tremendous increase, which means 23% of the traffic will be due to voice, text, and other applications, but 77% will be due to internet. This is a tremendous amount of traffic that will be due to video. So we need to understand well how the video applications behave in wireless networks, which are normally used as access networks to these applications. The trend also is not so bad in the developing countries. For instance, in Tanzania, statistics shows that over 50% of the population can have access to internet connectivity, which means a lot of people out of 60 million population, about 30 million people can access internet. This is the case for Tanzania, shows promising applications of internet technology. So now the questions that arises here, what will be the quality of those video streaming perceived by end users? And now the terminology that is used to measure quality experience by the people is what is called the quality of experience. And according to ITU, the quality of experience is defined as an overall acceptability of an application of a particular service as perceived subjectively by the end users. And now it is a little bit different from the quality of service, which is a measure of the performance of the networks that deliver a certain service. But the quality of experience, we want to understand what are the user's perception on a certain application. This is the network ecosystem, the typical one. The service provider that offers, that provides the video streaming applications, host the application somewhere in the cloud, and the infrastructures in the cloud are connected to the core network, a certain core network, which is a high capacity transmission network, which contains other, sorry, which consists of other nodes, which does the billing, etc., etc. And this high capacity core network is actually implemented by broadband networks, such as the fiber optic links, which are facilitated by high capacity transmission systems like the SDH and the DWDM, which is the dense wave division multiplexing technology and the synchronous digital hierarchy network. So with optical broadband networks, we understand that the propagation behavior is almost the same. We can understand the losses that are in the link. We can understand the dispersion, etc. So the engineers can design a network to a certain range by taking care of the losses that might be introduced within the link. And normally, the core network is connected to the access network, that provided an interface to end users, and the end users are connected to the access network by using their devices. Can be smartphone, can be computer, can be tablet, etc., etc. However, the challenge arises here in the wireless network. Let it be the Wi-Fi, let it be the UMTS, the 4G, the 5G, etc., etc. So long as they are operating in the wireless medium within a specified frequency spectrum, the propagation in the wireless medium is not constant. It varies a lot, and it can be impaired by different parameters. And these impairments actually introduces introduced by certain factors, have a certain effect or influence on the quality of experience that is seen by end users through their devices. So it is of huge interest for the operators to be able to understand the customers' experiences based on the network performance and other parameters that involved in. A number of studies have actually tried to study end users' perception by using a number of parameters from the network layer. However, a number of studies have attempted this approach by studying how one parameter affects end users' quality of experience. But in the networking level, just like this one, customers can be impaired by multiple parameters like the delay, the packet loss, the jitter at the same time. So we need to understand, in the presence of all these parameters, what will be the quality of experience at the end users, and what should be the strategies to make sure that the network performs at the levels that is expected by end users. So this study had two objectives. Number one is to study the perceptual effect of wireless network impairments on the user's quality of experience. And number two is to identify the most influencing impairments in the presence of several others, so that network engineers and administrators might be in a better position to design appropriate strategy to get rid of the impairment based on the level of resources that are available. Coming to the research methodology, this study was adopted a quantitative approach, and the emulation technique was used to provide environment for data collection. And the emulator was developed by using a Wi-Fi access point, which was connected to the content servers. And the network environment were varied by using the test bed, sorry, by using an emulator that was implemented by using the Linux kernel's networking tools. The mean opinion score was used to measure the quality of experience, and the mean opinion score is a tool recommended by the ITU in measuring end users' quality of experience. The network impairments that were emulated were the packet loss, which was measured in percentage of the number of packets that were lost during a certain session of transmission, the delay, which was measured in the millisecond, and the jitter, which was also measured in the millisecond, as indicated in table number 1. And the variables were varied at 3 levels, as indicated in table number 1 as well. Experiments were designed by using the Taguchi method that offered the 9 experiments in a session by using the orthogonal array number 9. Unlike the Factorial Design, we are supposed to test 27 conditions, which are quite a lot. But with the Taguchi standard orthogonal array, only 90 experiment sessions were valid to collect a sufficient amount of data for the analysis. And the rows indicate the setup of each variable in each experimental session, and the output recorded is the mean opinion score obtained by a number from the number of participants that participated. The experiments were participated by a number of 20 participants, where 7 were female and 13 were males. And a total of 540 data points were generated from a number of experiments that were conducted. Coming to the data analysis, this study wanted to understand the impact of which variable on quality of experience. And we found out that the delay and the jitter had significant impact on the video streaming quality of experience, above 95 confidence interval, whereas the packet loss could not account above 95% confidence interval. And we wanted to understand the interaction effect of variables and their effect on quality of experience. We understood that among the 4 interaction effects that were performed, the interaction effect between the jitter and the packet loss had a certain impact on quality of experience, though it was not above 95% confidence interval. Understanding the level introduced, we can see the gradient of the delay on quality of experience. The delay had the highest gradient, followed by the jitter, and the least was the packet loss, meaning that delay had the highest level of quality of experience, high level of impact on QoE compared to jitter, followed by jitter and then packet loss. So we can understand that beyond 150, the delay with the quality of experience becomes intolerable, and beyond 20 millisecond jitter, the quality of experience also becomes intolerable, whereas the packet loss at the ranges investigated were introduced the impacts which are not significant on the quality of experience. In a conclusion, we understand that video streaming is the most killer applications in the wireless networks. So we need to understand how it is being affected by the impairment in the network level. Thanks to the TCP protocol that assists in the correction of the packet loss by commanding the retransmission from the sending nodes, but the effects of delay and jitter actually needs to be addressed, and this can be done by proper dimensioning of the network. So the network engineers and system administrators during the management of the services and the networks need to make sure that the network is being dimensioned in such a way delay and jitter are very low, because they will impair the video streaming applications. One of the limitations of this study is that our approach actually was based on emulation technique in a laboratory environment, and we considered the only 3 impairments from the network level. Future studies should be done by considering more realistic network environment and extend the horizon of impairments that might have potential impact on the quality of experience in order to explore more how do they affect the quality of experience. Having said so, I want to appreciate you for your time. Thank you for listening, and I return the microphone to our coordinator for.
Thanks, Alex. Can you talk us through some of the pros and cons from your perspective of using the Taguchi approach? You know, I think people understand many of the benefits, but if you could explain them in a little bit more detail and also talk about some potential disadvantages, if any, that you experienced.
Yeah, thanks, Paul. Actually, in the experiment designs, we have a number of approaches that can be used. For instance, the Factorial Design. It allows a researcher to study different variables at different levels. But if you have more than 3 variables, and let's say you want to test the impact of the variables at different levels, let's say 3 levels, with Factorial Designs, you are supposed to set not less than 24 experiments to test all possible combinations. So if the number of variables increases, let's say you have 4 variables and then you want to test them, each variable at 3 levels. Let's say level 1, level 2, level 3 for variable 1, again, level 1, level 2, level 3 for variable 2, etc., up to variable 4. To get the total possible combination of the variables for 4 variables, you will need to have 4 power 3 variables, which is around 40-80 experiments. So the Factorial Designs, as the number of variables and levels increases, the study becomes complex. But Taguchi Approach was designed by Professor Genichi Taguchi of Japan, is used to test different variables at different levels by using a certain orthogonal array, which was derived from mathematics point of view, that can offer a fewer number of experiments, combination, which gives you an optimal set of variable combination. So it gives you the required results. At the same time, you are saving the number of experiments, which translates into the resources that are going to be applied in the design of the experiments and the conducting of the experiments in the laboratory.
No, thank you very much, Alex. I think that's a very useful explanation of the benefits. And then some of the disadvantages, I don't know if any of them impacted on you. So for example, randomization is not normally used to prevent environmental bias, and there can be problems with 0 degrees of freedom. So do you have any comments in terms of how that impacted on you, if any?
Yeah, randomization is happening, and the selection of participants who are coming into who participates into the experiments, because and also the way how one experiment condition happens actually is not known to those participants, and a certain code. For instance, in this study, it was the conditions were selected randomly by the emulator. So it is not easy for participants to understand which conditions will be brought, let's say in the next session. So a combination of techniques actually tries to achieve those conditions which are very important in conducting the experiments.
Thanks, Alex. Any other questions or comments for Alex? I don't see anything in the chat. Thank you very much. So the next presentation is by Emmanuel, who's going to discuss a multi-level clustering model for coherent topic discovery in short texts.
Hello, everyone. My name is Emmanuel Maithya, a postgraduate student at the Jomo Kenyatta University of Agriculture and Technology, Kenya, and also a lecturer at the Kenya Institute of Highways and Building Technology. I'm here to present our paper entitled A Multi-Level Clustering Model for Coherent Topic Discovery in Short Text. This paper has been co-authored by Dr. Lawrence Deru and Dr. Dennis Jagi, both of Jomo Kenyatta University of Agriculture and Technology. Our area of focus is topic modeling, which falls under natural language processing. The purpose of topic models is to extract words that most accurately describe document collections. For example, if you had a collection of newspaper articles, then a topic model should be able to extract the words from these articles, which would most probably form the topics of these articles. Topic modeling has plenty of applications. One of them being the empowerment of decision makers to quickly form opinions without having to look at numerous collections of data. The topic models would examine this data and present the words that most accurately describe what is contained in the documents. Specifically, we focus on modeling topics from short texts. We know that in the world today, high volumes of short texts are generated, for example, through the short messaging services, which are provided by mobile providers, as well as other web-based platforms such as Twitter. This has made the concept of what really a document is to change in order to incorporate the so many short texts that are generated from day to day. From our research, we have noted that short texts constituted from different words can convey the same meaning. And this view is supported by Qiang et al. In their research in 2019. The problems associated with modeling topics from short texts include limited word concurrence information. This problem is also known as the data sparsity problem, and it leads to the generated topics exhibiting low semantic coherence, making them to be less interpretable. Researchers have proposed the aggregation method as a method for remedying the problem of data sparsity. However, these methods are not universally applicable simply because they rely on metadata such as user information and titles, which is not always available. For related work, we've examined many pioneering techniques and recent techniques. The pioneering techniques include the latent semantic analysis or latent semantic indexing by Dewey in 1990, which technique was improved by Hoffman in 1999 to the probabilistic latent semantic analysis, that is a PLSA. And David Blay in 2003 came up with a latent Dirichlet allocation topic modeling technique, or the LDA, which method has been among the most popular method of topic modeling, leading it to be improved or to be relied upon by others in the form of improvement, first by the same author, that is David Blay, to the correlated topic model in 2007, and then Rosen in 2010, he proved it to the other topic model, which seeks to incorporate authorship information into the generated topics. Later, in 2015, DAS came up with the Gaussian LDA, and in 2013, previously in 2013, the BITAM topic modeling technique developed by Yan, which was specifically designed to model topics from short text. However, researchers noted that BITAM topic modeling leads to the topics being dominated by common words. The purpose of our research was to propose a multi-level clustering model that, one, overcomes the problem of data sparsity in short topics, and secondly, a model that is able to model coherent topics that are easily interpreted. We also sought to assess our model by implementing it, as well as 3 other conventional models, that is the LDA, the Gaussian LDA, and the BTIM. We did this by developing Python programs, rather programs in the Python programming language for this model, and then computing the coherence scores achieved by the topics generated by these models, and then finally comparing the scores achieved by all the three models plus our model to determine whether our model achieves its stated objective. Our methodology, the first step is dataset identification for our model. We identified 3 datasets. Number 1, the traffic offenses dataset, which is a listing of traffic offense descriptions committed for offenses committed in the county of Montgomery in Maryland, USA. Secondly, the equivalence dataset, which datasets consists of short descriptions of the justifications provided by prospective borrowers. And then finally, an indigenous African dataset based on the Swahili language. Secondly, we sampled our short texts using the stratified sampling method, whereby we group the documents or the short text in our datasets, and then we select a single short text from each group. The idea of which is to limit the number of short texts that will be taken for processing in order to reduce processing time, as we know that topic modeling techniques can be resource intensive and take a significant amount of time to execute. The third step is to remove stopwords. These are words that are common throughout the document collection and have no significant meaning. We also removed, or rather we also remove numerical and single character words. In the 4th stage, we form our n-grams. N-grams are formed from level 2 to level n, and this is done on a sliding window basis. The level n is determined by the longest short text in the sample extracted from the dataset. After sampling, we model our topics. This is done by first clustering the n-grams at the different levels, that is starting from level 2 to level n. To do this, we use k-means clustering. In k-means clustering, what we need that is required to determine K, that is the optimal number of clusters. And this is done by using the elbow method, whereby we plot the within cluster sum of squared errors against different values of K, and obtaining the value of K that falls at the elbow, which value is the number of the optimal number of clusters to be found within the data set. After clustering, we go to our final step here, which is isolating the clusters which most closely match with the n-grams, and this is done by doing cosine similarity, or rather taking cosine similarity measures between the clusters and the n-grams, and isolating those that have the closest match. This diagram is a depiction of this methodology, short text data set illustrated on the leftmost part. The sampling and pre-processing is done in the second step, and then a depiction of the creation of our n-grams from level 2 to level n, after which we do the clustering of these n-grams, and finally, as shown in the diagram, the topics are extracted by comparing the n-grams and the clusters. From our research, we determined that our n-gram cluster model achieves higher coherence scores when compared with the other three conventional models. Our modeling technique is also able to generate topics that are easily interpreted. We also noted that our technique performs consistently across different data sets, and that is the Swahili dataset, the equivalence dataset, and the traffic offenses dataset. We also determined that our clustering model, n-gram cluster model, is applicable to indigenous African languages, and is vindicated by its applicability on the identified Swahili dataset. We present the chart to illustrate and show the performance of our model against the other models. The performance of our model is shown using the blue line. The coherence scores are plotted against the top n words, and coherence scores most closest to 0 are deemed to be the best, and therefore this shows that our n-gram cluster model performs better than the other three models. Here we show a listing of the top best 5 topics extracted from the traffic offenses dataset. Topic 1, valid medical examiner certificate possession. The second topic, careless, imprudent manner endangering property. From these 2 topics and the other shown in the table, it is clear and it's evident that our model is able to extract topics that are easily interpreted. For future research in topic modeling, we suggest that research should aim at further improving topic coherence for topics extracted by the models. Secondly, researchers should seek to extend the applicability of the topic models they propose to as many other languages as possible. We also notice that topic models, the running of our topic models is rather resource intensive in terms of memory and time. So we propose that future researchers seek to optimize the algorithms to enable efficient resource utilization by the proposed models. And finally, for our model, we used the k-means clustering technique it would be of interest for future researchers to consider other clustering techniques such as the DP scan and the mean shift, and then measure the performance of such models against the performance of the model that we have presented. Ladies and gentlemen, that is the end of this presentation. Thank you.
Thanks, Emmanuel. So we're going to start with Awuni and then David.
All right. Good morning, everyone. This is Emmanuel here. Let me thank you very much, Dr. Awuni, for the question. The size of a short text is really basically comparative, because topic modeling techniques have been developed, focused on extracting topics from huge or rather quite lengthy documents, like the examples that are given of newspaper articles. And I would like us to compare that one with the really short text messages, which really probably constitute of something up to like 20 words, and also the tweets. And for this data sets that we identify, that is the traffic offenses data set, the equivalence data set, and the Swahili data set, the average number of words in these data sets was 7, 8, and 18 respectively, as we have pointed out in the paper which we are proposing for publication. So really, short text is comparative. The term short text is going to be comparative between the naturally inherently short text, which because of the nature of communication just have to really simply be short, like SMSs, tweets, and so on, against comparing these with the lengthy normal texts that we find probably from newspaper articles. So that is my response to Dr. Emmanuel. Thank you for the question.
Thank you both. David?
So my question was, because of a very good presentation and good research. So my first question is, what was the dataset size? And so you applied the method of Swahili and other indigenous languages. So what were the issues of when you applied that to those languages? For example, we have code switching between Swahili and English, or anything like French. So what were your issues that you got, and did you attempt to try to use like a metric to quantify the clusters, for example, a silhouette score, for example, like that, to quantify each cluster?
Okay. Well, first to the dataset sizes. The largest of these data sizes was the traffic offenses dataset from Maryland, Montgomery, Maryland. It's about 500 MB, as actually also indicated in the paper. The equivalence data set is slightly smaller in size, and the smallest of these was a Swahili data set in terms of the megabytes. Okay. Our application of the method on the Swahili data set produced the same kind of results across the board. I think on the paper, on the published paper, or the other report that we are proposing to publish, we have also given out the chart of the results that we obtained after running the modeling method on the three data sets, and the performance of this particular modeling technique is consistent across the board. So if you look at the topics, our metric of measure for performance of the data sets is on the coherence. And when you look at the coherence, the scores achieved across the board, it exhibits consistent performance, regardless of the data set that has been was used. I don't know that I've really answered your question. I think there's something if you raised, so at least two issues. The third one, maybe you can repeat. Have I answered your question? Or
So
maybe
yes. What might have your issues on Swahili?
Issues?
Yeah.
Oh, let me say that the purpose of really applying this method, or rather using the soil data set as one of as part of the data sets that we applied for our experiments, was basically to weigh, or rather to find out whether the method that we've developed could also be applicable to indigenous language. And really, when we look at the words, or rather the output of our model, we realize that we are still also able to get easily interpreted topics. These topics, perhaps for the English language, all of us are English speakers, hopefully, so we're able to really tell. We're able to look at the semantic coherence. Anybody looking at the words that have been extracted from the Swahili data set will be able to also see that if they are Swahili speaker, they would also be able to really see that the topics that we have extracted using our model are also easily interpreted, just like the ones that we got from the English data set. But in terms of running the technique on the various data sets, the performance was simply just consistent. Similar. So that's my response. Thank you.
Thanks very much, David and Emmanuel, for that exchange. So if there are no other questions for Emmanuel, our next presentation is from Ednah, who's going to talk about stacked language models for an optimized next word generation.
Good day, everyone. I'm Ednah Olubunmi, a postdoctoral research fellow from University of Free State Development in South Africa. On behalf of my host, Professor Edwin Kotze, I'm presenting a paper titled Stacked Language Model for an Optimized Next Word Generation. The content focus of our presentation is specifically on language modeling, the task of predicting next word, given the word so far. The structure of our presentations covers the motivations, the objectives, the research methodology, our results, and conclusion. The components responsible for writing human natural language text in NLP is NLG, natural language generation. A subcomponent of machine translation, conversational agents, text summarization, creative writing, text prediction, which is the focus of our presentation, deals with generating words by repeatedly sampling sequences of words conditioned on previous choices. The system that are responsible for these probability distributions are the language models. And we have different types of it. Statistical language model, neural network language model, transformer language model. But our choice of language model is neural network language model. The research work is inspired by the work of Mongi 2019, where they employed the use of LSTM to generate text with word-to-vec keyword embedding and one-hot representation. The choice of using stack layer neural network model is motivated by the highlights presented in Grave et al. 2013, that the depth of a network is more important than number of memory cells to model a skill. From this point on, we draw our research questions to know which stack model is the most optimal for next word predictions. Our research objectives. The specific objectives of this research are to design a word prediction model using state-of-the-art deep neural language models, like the stack layer LSTM, stack layer JKUAT, and stack layer BiLSTM on top of unidirectional LSTM. And two, implement the network prediction techniques and compare them in terms of predicting next word. Our research approach. The corpus used for this experiment is downloaded from the Project Gantt library. Reprocessed and tokenized using tokenizer package from Keras. We employ sequential model API from Keras to capture the meaning of words through length embedding, which get converted into sequences of vectors. So this sequence of vectors serve as input to the model. The model one represents the two-layer LSTM. The model two represents the LSTM stacking on top of unidirectional LSTM. The model three represents the two layers JKUAT. So the encoding the sequences of vectors, and they get converted into another sequences of vector called the hidden state. So the hidden state of the first layer serves as input to the second layer, and we have the final hidden state. The final hidden state gets passed into the linear layer to get a set of scores corresponding to the total vocabulary size. In order to get a single score for each word, which we refer to as logits, linear layers are flattened and get concatenated. This score is passed into the softmax layer, which get then converted into probabilities. We train the model in order to measure how far apart two distributions are using categorical cross entropy. And we also employ the use of adaptive moment estimation for the optimizations. Then finally, at the inference stage, we employ the greedy decoding algorithm, which maximizes individual weights. That is, it takes the highest score at each stage using arguments, mathematical functions provided in NumPy. Then we design the system by, we implement the system using Python 3.7, TensorFlow 2.6.0 with Keras and a NVIDIA graphical processing unit. Table 1 shows the performance evaluation between the current study and the existing work. The existing work used different attributes, like they use different topic theme, different vocab size, then only single layer by LSTM, different number of epochs. But the current study used the same attributes and takes advantage of different parameter configurations, which maximizes the model predictive accuracy in terms of how much correctness would our models predict. In table 2, it shows the model prediction results, where the stack LSTM predicted all the sequences correctly. The bi-LSTM stacking on industrial LSTM predicted 8 sequences correctly, and stack GRU predicted 7 sequences correctly. So from the experiments carried out, we shows vividly that 2-layer LSTM is the best model for next word generation. In conclusion, the paper presented a model for next word prediction using different RNN-based architectures. So our further improvements and extension are to using the transformer model for more dynamic text generation, adopting more decoding strategies like beam search algorithm, which maximizes sequences of words, understanding models thought process, that is, to know how neural network models learn features. And finally, we intend to use these language models for low resource languages to predict next word generation. We acknowledge research, innovation support, and advancement division, which is division of National Research Foundation for their financial support. Thank you for listening.
Thanks, Ednah. Can you talk us through some of the key potential benefits and associated challenges of the proposed approach in the context of local African languages? So my understanding was that the samples used were in English.
Thank you for your question. As you know, the backbone of these our mobile
Ednah, can you try again and check if you're muted? We can't hear you.
Thank you. Are you hearing me now?
We can hear you now. Thank you.
Okay, thank you for your question. Like what I'm saying is that using our own language and language for our low resource language for next word prediction, in Africa, we still lag behind in this area. Comparing to the Asian country, European country, where they have their own instant messaging applications. Like in China, where they use the WeChat. The WeChat is based on, is English based and their own local language based. So that's where we are tailoring the research to. But this is just the beginning, the starting point of our research work. We are still going to look at some of the African languages, at least one or two, to use it to generate our own low resource languages. So that's where the research is still going to. Thank you.
So I may have misunderstood, but I understood that the samples that you were using in English language were novels, you know, Pride and Prejudice, for example. So are you looking at using similar large bodies of text in local languages?
Yes, we are going to look, yes, we are going to, that's the major problem in this study is to get the data set, to get the data. That's the major problem. You know, we don't have there is no ready-made data on ground, but like the data set we use for this work is based on, is a storybook. So we can start from then using our own storybook, maybe in South Africa languages, or what have you. So we can start from there. But what we are doing is that because we are still working on a particular research area in the school where we are collecting the data set from the students, maybe during that is, we want to make sure that we collect data sets based on what is going on in the campus. Then we are now going to interpret it into our own languages for us to be able to come up with our own ideas.
I understand. So if there's anybody in the meeting or anybody who's got contacts that they can reach out to afterwards who can help Ednah in terms of getting access to necessary corpus in local languages, I'm sure that would be much appreciated. Are there any other questions or comments for Ednah? In which case, thank you very much. And the last presentation in this session is from Emmanuel, who's going to discuss public sentiments in user-generated content amid COVID-19 pandemic in Ghana.
My name is Dr. Emmanuel Awuni Kolog. I'm actually a senior lecturer at the University of Ghana. I hold a PhD in computer science. So basically, my presentation is going to be centered around public sentiments, user-generated content amid this COVID-19 pandemic in Ghana. We all know how this COVID-19 hits the world. That was in 2019 in some parts of the world and eventually became a pandemic. However, in the African continent, it was only on the 14th February 2020 when Africa recorded its first COVID-19 case in Egypt. Well, in Ghana, since the study is going to be centered on Ghana, so in Ghana, we recorded our first case on the 12th March, that's 2020. And basically, when the COVID was recorded here in Ghana, it actually generated a lot of emotions and panic in the system. So many people couldn't have the opportunity to probably get onto radio stations to express their sentiments about the pandemic. So what they could do was to actually use the social media platforms to share their sentiments and also views and issues about how the Ghanaian, let's say, the government is actually handling the COVID-19 situation. Well, it was actually difficult. It was difficult to understand public sentiment at the time, even though the government had some kind of management team managing the COVID-19 situation in Ghana. You know, try to understand people's sentiment, people's mood, helps you to be able to manage and control the pandemic. As I said, at the time, there was no way by which, you know, the COVID-19 team could somehow understand public sentiment regarding the COVID-19. So actually this gap motivated the need for this study where I leverage on computational techniques to understand public sentiment. And actually the goal is to help influence policy in terms of COVID-19 pandemic management and control. So this study is centered around two main objectives. One is to track public sentiment from tweets amid the COVID-19 lockdown period in Ghana. And then the second part is to also explain the impact of the COVID-19 pandemic on public mood. You know, at some point where, you know, many countries were closing their borders, Ghana also somehow closed its border and then instituted some measures to control and manage this pandemic. As a result, there was a lockdown period. So this study, we actually scrapped data from Tira, from the period of the lockdown, and Ghana experienced 19 days lockdown period. And the study looks out at the public mood or public sentiment at the time of the lockdown period. You know, if the nature of the public sentiment can even polarize or explode, you know, it can polarize the state in a way. If Ghanaians or people are not actually happy about how the pandemic is being managed and controlled in this country. So the study looked at that. Now the data sets. So I used actually Tira API and a Python script, and I wrote some Python script to scrap data from Tira. And you know, since the study centered around the lockdown period, that was from 30th March to 20th April in Ghana here. So I had to set some kind of keywords in order to collect the data. from Tira. So keywords like COVID-19, SARS-CoV-2, and coronavirus, and also set the geographical area to Ghana. So in the end, a total of 23,784 instances of tweets were scrapped during the lockdown period here in Ghana. All right, so if you look at the screen right now, this is the table in terms of the reported cases in Ghana at the time within that period, within the what we call the 3-week period, lockdown period in Ghana. So if you look at the table, the day one of the lockdown period, the number of tweets at the time was 184 based on our criteria. At the time, there was no case for the first day. On the first day of lockdown, there was no case. And then, however, cases had already been gathered before the lockdown period. And the total number of cases was 152, and there was no deaths. So if you look at the total deaths at the time, it was only 5 before the lockdown period. So if you go down, the last day of the lockdown, you see that the total number of cases or the number of tweets regarding this COVID-19 or based on our criteria was 2,093. Then the new cases were 208, and of course you have the total cases, and then the total deaths, which was around 9. Okay, so now let's look at the tweets. Let's delve a little deeper into the tweets. If you look at the tweets, many of the tweets actually generated were by individuals, and probably or hence inherently reflect the views of persons who may, or in one way or the other, have been affected by the lockdown due to the COVID-19 pandemic. So if you look at the table right here, you have tweeters, those who tweet, and the number of tweets. So basically, we categorize those who tweet within that lockdown period according to the individual tweets. Tweet also from television stations and also tweet from the radio stations. And there were other tweets as well, apart from radio, television, and individual tweets. There were other bloggers and all that who also made some tweets. And if you look at it, the highest number of tweets within the lockdown period came from individual, and that is 20,234. And of course, followed by other tweets, and then radio stations, and then the television stations followed after. Now, so we did a pre-processing of the data. We leverage on NLP and machine learning techniques to be able to analyze the data, to track sentiment from the data. So like I did mention, the instance of the data, which was 23,000, a fraction, which is 10% of the data, was manually annotated. What happened was that I set up, predefined classes of sentiment, which is negative, positive, and neutral from the text. And I gave it to 2 people. Basically, I gave it to first person, who is an annotator, to read the content and annotate whether the content or instance of the instance of the data is positive, negative, or neutral. After that, I gave it to another person who looked at what the first person did, and then also either agree or disagree. So eventually, the disagreements, I made the 2 annotators, and then we were able to fashion out the discrepancies in the data and agreed on one. So this is how the data was annotated, because the idea is to use classification technique, and in classification, we need the data to be annotated. So this data I actually leveraged on machine learning, 3 machine learning algorithms, support vector machines, a naive-based algorithm, and artificial neural network. So if you look at the instances of the data, I made mention that 10% of it was annotated. So the 10% which was annotated was actually used to train the algorithm. And then after training the algorithm, we then used, or I used, a model was created, and I used that model to predict the 90% of the unlabeled data sets. And that's the first instance of the classification that I did. Now, because the classes were negative, positive, and then neutral, I needed to manage the data so that I will eliminate what we call imbalance classification. So what I did was that I made sure that the same number of tweets for the neutral is also for positive and also negative, which I use to train the machine learning algorithm. And of course, the 90% unlabeled instance of the data was actually classified based on the 10% which was used to train the machine learning algorithm. So after that, I did a second round of classification because the first round was for me to be able to get the remaining 90% annotated. So I did a manual annotation with the 10%, used that one with a machine learning algorithm to predict the 90%. And after that, at this second round of annotation, that in this case, I had all the data annotated, one part from the human annotation and part also from the machine learning annotation. Then I split the data again into 20% and also 80%. And I used the 80% to train all the 3 machine learning algorithms. And then the remaining 20% was used to test the algorithm to see how effective or the efficacy of those algorithms. So this is the diagram or the process map in respect of the use of the NLP and the machine learning algorithm. All right, so now let's look at, the results, the major outcome. So proportionally, well, it was observed from the study that as the number of reported cases increased, the number of tweets also increased, meaning that from the one, the reported cases were being, increased, or let's say a number was still being added, and it also corresponds to the number of tweets that people were actually tweeting. So this trend, well, may be attributed to the uncertainty regarding the virus during the lockdown period, because people were not actually certain about how the whole thing is going to end. Some people were of the view and treated that even the world was going to end and everyone was going to die. So it actually pushed a lot of people to tweet or write a lot on Twitter page. So consequently, people began to express their sentiments on Twitter and other social media platforms. So generally, the high negative sentiment occurred. Generally, the high negative sentiment occurred as the week progressed. So this could be attributed to the prolonged uncertainty of the lockdown and the fear of gradual increase in the spread and consequent infection of the COVID-19 amongst students. Now let's look at this diagram. If you look at the diagram, the lockdown period was 3 weeks, starting from 30th March to 19th April 2020. Now, if you look at the diagram, I've divided the diagram into 3, week 1, week 2, and week 3. So if you look at week 1, the yellow represents total cases reported, the brown, which also represent negative, and then the ash color also represent neutral sentiment expressed by people who tweeted during the period, and also the red, which is the total deaths. So if you look at it, you realize that the number of positives fluctuates in a way. So if you look at the first week, it started in the low notes, dropped down, and then move up, meaning that move up on the 5th April 2020, meaning that people were actually expressing a negative sentiment, not positive, negative sentiments at the time. So people were quite uncertain about the pandemic. So in the second week, the negative sentiment somehow dropped in a way, somehow. On the 9th April 2020, as you can see from the figure, the negative sentiment actually dropped. And then people were actually anticipating, or they were expecting, that the lockdown would be lifted at the time. And the total number of cases increased. So if you look at the yellow diagram, you realize that that's the number of cases. You realize that the total number of cases were shooting up. So on the 9th April 2020, because the total number of cases were shooting up from that time till the end, which is the 19th April 2020, you realize that the negative sentiment also moved up in a way, came down and then moved up again. But surprisingly, there were some positive sentiments also expressed in the tweets. As you move, I think within week 1, the positive sentiment wasn't that much. It went up a bit in 3rd April 2020, and then came down. The positive sentiment came down on the 4th April 2020, which correspondingly, you see that the negative sentiment also shoot up. Now, if you go to so somehow it was a bit steady, the positive sentiment was a bit steady until 17th April 2020, 18th April 2020. At the time, it was clear somehow that the lockdown was going to be lifted, so people were excited. That is why the positive sentiment also shoot up. Okay. Now, so while the latter part of the first week saw some Ghanaians expressing positive sentiment, the highest spike occurred basically on the 18th April 2020 when the ban on lockdown and restriction of movement was actually lifted. And I think that I've already explained that. Okay. Now, I also explore the keywords that Ghanaians actually expressed during the lockdown period. And if you look at it, coronavirus Ghana, COVID-19 Ghana, coronavirus were the pronounced keywords that people actually expressed, meaning that at the time, people were only much focused on the term COVID-19 and then COVID-19 in Ghana. Now, so eventually the classifier needed to be evaluated. So if you look at the diagram there, we have artificial neural network, support vector machines, and the naive-based algorithm. And then if you look at it, we explored the precision, recall, and F1 measure for both algorithms. And then if you look at the accuracy, all of them exceeded the threshold of 70%, meaning that all the algorithms actually did well in predicting or tracking sentiment in the text. However, SVM classifier yielded the highest accuracy, followed by the artificial neural network and also naive-based algorithm. And the fact that they all exceeded acceptable threshold of 70%, meaning that the algorithms did well in terms of tracking sentiment in text. So in response to the pandemic management and control, in conclusion, we can see that the data has shown the mood of Ghanaians during the 3-week COVID-19 lockdown period. So I actually envision that this study will guide policy on the management of pandemics, management of public sentiment, should there be lockdown again or lockdowns in the future. So basically, the study somehow could help Ghana Health Service in terms of giving advice in terms of healthcare, people's mood sentiments at the time of the lockdown. And then the high level of the negative sentiment could mean so many things, including the dissatisfaction expressed by people towards the management of the pandemic. So the whole idea of the public sentiment could also give a fair view about confidence that people had on the government in terms of the management and then control of the pandemic. And I believe that in future, these findings will give, the team, or for them, if they are going to evaluate their performance, the finding is a way to tell how Ghanaians actually felt about the management of the pandemic in Ghana. Thank you very much.
Thanks, Emmanuel. So our first question is from Emmanuel from Kenya.
Hello. Well, I posted the question on the public chat, and I was just requesting maybe you can comment on the applicability of the technique that we've presented to us on similar situations which could probably be occurring now or maybe in the future. COVID-19 probably we may have another pandemic coming up in the future. So that's my question. Thank you.
Well, so in fact, I wasn't so clear with the question. Please, if you can, do you mean if this research, the findings is applicable in future pandemic also? Can you re-echo the question again?
Yeah, that's my understanding, Emmanuel. Emmanuel is asking you how this could be applied to future pandemics in Africa.
Okay, yes, thank you very much. This study, to the best of my knowledge, is actually the first of its kind, especially leveraging on these computational techniques to do this. So basically, getting this finding out is a way to create the impression to the minds of the policymakers that this kind of studies can be done in future. Should they should we have a pandemic-like situation? What it means is that they could trigger this kind of study, which there can be a real-life sort of analysis of public sentiment, emotions, and mood, so that the government can be guided in a way by the findings or the real-time findings in order to manage and then control the pandemic. And then also, in a way, the findings of this study also goes to show that somehow Ghanaians express some level of sentiment, during the pandemic. And of course, I've elaborated on the spikes in terms of the emotions and all that. So, one thing about public mood or public sentiment in a way can even explode, which can even cause a problem and polarize a state. It could not necessarily be pandemic situation, but it could be a situation whereby even government policies and how it's rolling out its programs. So I think that somehow the activities by the government can be explored, because it's not everyone that gets the opportunity to be on television stations, radio stations, and all that to express their views, sentiment about government policies in respect of pandemic or whatever. So basically, this study is just to create that sort of awareness also in the minds of the policymakers. I don't know what I thought.
Yeah, thank you. So can you talk a little about the distribution of languages used in the corpus of tweets that you analyzed?
Okay, so basically, the language was purely in English. Ghana is we're colonized by the British, so our official language is English. And then normally within our context, people tweet in English rather than the local language. So basically, the data that was scrapped from Twitter, we did not actually, get a language tweeted in our local language. So they were all basically in what we call the English language. Let me put something across here. Within our context here, if you look at social media platforms like Facebook, Twitter, and others, Twitter itself, that we have categorized them in a certain class. So people that normally use Twitter, they somehow make their tweets in English. But if you go to Facebook, on Facebook, yes, we have other people that also tweet in our local languages. Who also type or maybe write in our local languages. But in Twitter, it's a bit different because of the category. It is perceived that a certain language should be used. That is the English language used in the Twitter. And another, I could have also used Facebook data, but the issue is that, we know the challenges associated with scrapping data from Facebook. So, Twitter for research purposes, we're able to use the API to scrap the data and analyze.
Thanks, Emmanuel. It's interesting how perceived social pressure might induce content to be published in a certain language. I find that very interesting, especially as you notice that it could be in a different language on a different social media platform. The other issue that I'd like to briefly tease out is how did you distinguish between dissatisfaction with government actions related to COVID, including communications and the lockdown itself and the uncertainty about the lockdown, and then the dissatisfaction generally of people with the perceived risks and anxiety associated with the public health crisis? So I understand that the communications is in the control of the government, but how people are responding to a public health crisis is something different. So how did you distinguish between the motivations of the tweets, between general anxiety and specific discontent with the action or lack of action that was perceived to have been carried out by the government?
Well, that's a very good question. Frankly speaking, the study actually just took the data analyzed, and I did not actually look at the content that basically reflect on government action. But the perceived or the assumption is that the COVID situation was purely managed by the government. And because it was purely managed by the government, even though people were not happy in respect, people were of course, their state of mind was problematic in respect, based on the fact that the COVID has actually come. But majority of the tweets in a way reflect on government actions in terms of the pandemic. Let me give one example. During when the COVID came into the system, somehow there were majority or people were calling the government to lock down, or let's say to close our borders so that it will stop any kind of COVID coming into the country. But for some reason, that was the public outcry. But for some reason, the government did not heed to that. And then all of a sudden, we had cases, and those cases were as a result of imported cases from other countries. So this actually somehow exploded in a way. So people were angry somehow until the government, at some point, he decided to, lock down the system. Even the lockdown, there was a cry from the citizens that the government should also lock down the country, and he did not heed to that until somehow escalated before he did the lockdown. So the study, in fact, the data also is premised on the assumption that people's tweets and what have you was as a result of government actions in terms of the management of the pandemic and all that. And then this is not scientific, but somehow within the content of the data, we realize that most or many of the actions or many of the comments were also towards how the government were actually managing the pandemic, even though not entirely. Of course, some of them were not also happy because the pandemic has actually come. Thank you.
I take your point, Emmanuel, and I think it's interesting because obviously in different countries, the lockdown means different things. In some countries, lockdown simply meant stopping people crossing borders. In other countries, it meant that people were supposed to stay at home, or they were supposed to minimize contact with people beyond their families. So I think for the future, as you do further research in this area, being able to disambiguate between the motivations and the issues that people were focused on, I think would be genuinely interesting from a public health messaging and communication point of view. So thank you very much indeed. So we're going to take a short break now, and the next session is going to start in about 5 minutes. And that's going to focus on the first of a number of sessions on next generation computing. So we're going to have presentations from South Africa, Uganda, and Zimbabwe. So have a short walk around or a coffee or check your mail, and we'll see you back here at 10 after the hour. Thank you.